Good day, everyone, and thank you for joining our Cognitive Systems Institute Group speaker series. And Happy New Year. This is Diane Fodell. I'd like to introduce today our co-presenters. Alun Preece is a professor of intelligence systems and the leader of the Knowledge and Data Engineering Research Group in the School of Computer Science at Cardiff University in the UK. Dave Brains is the technical lead for IBM UK Emerging Technology and is a fellow of the British Computer Society. Alun is the academic technical lead and Dave is the industry technical lead for the 10-year joint US and UK International Technology Alliance in Network and Information Sciences. This involves a consortium of academic, government, and industry partners. Both gentlemen are prolific publishers, and I will post their short bios in the chat. Please help me welcome Alun and Dave, and I'll turn it over to you, gentlemen.
Hi, everybody. So this is my voice. It's Dave Brains here from IBM.
Hello, this is Alun Preece from Cardiff. So I was just going to start things with a brief bit of background on this International Technology Alliance that Diane mentioned, and thank you, Diane, for that very nice introduction and for giving us this opportunity to talk today. Dave and I have been working together for most of the last 10 years on quite an unusual collaboration in that it's brought together the three cultures of academia, industry, and government, and a lot of the early stages of the 10-year program were us learning how to work together and our various approaches, strengths, expertises, and so on. But we've reached a stage where I think it's a fairly smooth-running collaboration, which is good because it's in its final stages, and there'll be a number of reporting events happening over the next few months and outputs, which I'm sure Dave would be in a position to share internally in IBM. So this research was motivated by the US UK Ministry of Defense to look at technologies to support coalition operations. But actually, it's a lot more general than that makes it sound, because much of what we've done is applicable to a wide range of situations where multiple partners have to collaborate and cooperate on difficult, typically decision-making problems in real time, and that's really the flavor of what we'll be talking about today in conversational sense-making. So hand over to you now, Dave.
Thank you, Alun. So I'll cover the introduction. Alun will be talking again in the middle, and then we'll both finish up at the end, and we'll take questions at the end in the last 5 minutes. So thank you. So there's a lot of background to this work, and we'll go over that very briefly, but you are welcome to read about it or contact either of us if you are particularly interested in any of it. We presented this work originally last year, which is where it says you are here, it has the date 2015, at a conference in the US in Baltimore. And the conversational sense-making title for this work is really exactly that. It's sense-making. It's related to situation awareness and making sense of your environment from an information point of view, but in this case via conversation. Okay, and the papers listed on this page are really some of the precursors to this work that have led us to where we are. Okay, so very relevant to this in terms of the background is the work of Paroli and Card, who tried to characterize the sense-making process for intelligence analysis, and this was based on the work that they had been doing previously. So they see this, and this is fairly widely accepted, although not universally. Some people have a different view, as a series of interconnected loops. There's a foraging loop and a sense-making loop. And basically, if you start at the lower left of the diagram and move up towards the right, you see that humans in an information landscape start off fairly unstructured with relatively little effort, and they increasingly schematize, they form hypotheses, they basically move up this scale, and the structure and the effort increases. And this is really the basis for the sense-making part of our work. Okay. The other thing that's relevant in getting us to where we are is we, in our previous work, have been reimagining what we call data to decision. So this idea of information flow between, for example, sensors and decision makers. What we're basically saying with the potential for conversational interactions is that you can reimagine these sort of previously linear stovepipe decision pipelines into something much more smart and conversational. I should also point out that these slides are quite packed with information. That was really the intent for the conference we presented at, and we're not going to cover every point on all the slides, but you're obviously welcome to refer back to it. Okay, so with that conversational thing in mind, if we come back to Parolli and Card again, then we see conversation as doing some really supporting forward and backward flows. It's not just a flow in one direction. We see our particular approach, which I'll talk about later, around what we call a controlled natural language, as giving us some structure from the start. So even in your most unstructured part of the process, you already have some structure, which is very helpful for machine agents. And really, endeavor here is about a team process. So we're trying to enable what we call co-construction of information artifacts, people working together. Okay, so let's talk a little bit about our human-machine conversational model. And I think this is really what caught the attention of this group, certainly Diane, in terms of the work we've been publishing. So we really want to support conversations between human and machine agents. We already know that we can have easy natural language conversations between humans. That's what we do when we do text messaging, when we chat face-to-face, talking over lunch, that kind of thing. That's full natural language, and humans are very good at that, and we're very proud of our language and all of its nuances and the ability to communicate very rich information. As I'm sure you all know, machines find this incredibly difficult. Natural language processing is a hard problem and will remain a hard problem for a long time yet. But we are making some great inroads. But we do want today to have these conversations between humans and machines, and in our earlier work we hypothesized that this focus on controlled natural languages, an example of which is in the blue box here, might be a really happy medium, a middle ground for humans and machines. So a controlled natural language, for those of you that are unfamiliar with it, is synonymous really with semantics, things like the semantic web representation language of OWL is all about representing knowledge in terms of the model and also the data. That's a knowledge graph. And traditionally, you use technical languages that machines can process to build these. But we're trying to do the same, but with this controlled natural language. So it is English. It's very, very structured English. It's easy to read. It's a little harder to write. So taking this earlier work of our controlled natural language, we actually reapplied some of the earlier work in the field on agent communication languages, speech acts, and some linguistic theory into a model of conversation where we have asks and tells and confirms. And what we want to do specifically is support conversational acts between agents, and these can be human and machine, they can be human to human, or even machine to machine. And it's worth just dwelling on that last one. What we're saying here is all of the agents in a system could communicate in English, albeit controlled English, even when it's machine-to-machine communication. And the reason why we might want that is because at any time, a human agent may want to see what the system is doing. They may wish to eavesdrop, they may wish to just see what the machines are talking about. Now, one thing we realized pretty early on is writing controlled natural language is quite hard, and it's not something you would do in a conversational setting. It's not fluid enough for that. We recognize that. It has to be the way it is. It has to be quite structured in order for the machines to be able to process it very simply without it being ambiguous in full natural language. However, for this conversational interaction to work, human users must use full natural language. They want to use this like a system like Siri or a Google keyword search. We don't want to be too prescriptive. So what we do is we use what we call a very simple bag of words, natural language processing. We have a model of the world. That model may be anything. It may be about disruptions. It may be about crime. It may be about anything. But what we do is when the humans start using words in natural language, we try to map them to the model and therefore interpret their meaning in the context. And what we do is we show that interpretation in controlled natural language back to the human user. And you can use this in many scenarios. We've done quite a few experiments and thought exercises. We've got some open source software, which we'll tell you about later. And we've used this in a number of settings: textual, graphical, voice to text. We've had Google Glass simulators and so on and so forth. So at this point, I'll hand over to Alan to talk a little bit about conversational foraging.
Okay, thanks, Dave. So returning you to the Piroli and Card model, which was basically two interlocking loops. And the first loop was the foraging, the gathering of information. Now, 2 slides ago, Dave showed you a screenshot from the conversational agent where there was a little bit of user input going on. We gave that agent the name Moira, which stands for Mobile Intelligence Reporting Application, and Moira is our, if you like, our Siri. It's the way into the system, and by giving the piece of software a name, people can kind of relate to it. And with Moira, we've run a number of studies to gain an evidence base that our approach can actually be used to forage for information. And once we've obtained information through the foraging process, we can start to do things with it. In a moment, I'll talk about some of the more controlled or limited studies that we've done, and then a little bit later I'll move on to talk about a study that was much more in the wild, but the images on this slide point towards that, and it was related to a major public event that happened locally in South Wales, which was that the International NATO Summit came to town, and we took a task upon ourselves to build a knowledge base of people and events, activities around that summit, and also to gather information in real time. So that's what these images are doing on this slide. But just before I get to that, if Dave, you could move me on one. So the next slide, please.
Okay. I have moved it.
Yeah,
Okie doke. Got it. And we conducted a number of initial experiments to gain confidence that the software was actually fit for purpose in terms of foraging. The first experiment we ran, actually we had 20 student participants who received no training in the controlled natural language or conversational technology. They used the Moira interface to describe what they saw in a number of scenes that we pulled from Flickr, which showed things like basically emergency services type people, police, fire, ambulance operatives in urban settings, and one of the pictures is on this slide. And that was quite promising in showing that from the input we could actually obtain a number of facts, median, a couple of facts per statement that the users made. So encouraged by that, we then did a larger study with 39 also untrained student participants moving around with mobile devices in a setting where we set up various scenes, and we asked them a bunch of questions that they could answer by telling the Moira agent what they saw. And the main result from that really was that the vast majority of users, 69%, actually managed to tell the agent something useful in terms of putting together the picture of the situation. The third thing we did was actually more a bit of public outreach. The British Broadcasting Corporation had a summer festival last year, and we took Moira along to the festival, and we got visitors at the festival to play a television trivia quiz using Moira. So we would give them the questions, and the only way they could answer the questions was by basically telling Moira, and we did it as crowdsourcing. We kind of programmed the agent not to know the answers, so the only way it could know the answers is if a number of people gave it the same answer. And what was interesting about that was these were members of the public, so not only didn't they have any training, they ranged in age from children, fairly young children, up to senior citizens. So it was a very encouraging piece of foraging work. Dave, next slide, please.
Okay.
All of these studies were basically allowing us to fill a shoebox in the form of the Piroli and Card model with information. And from that information, once it was mapped from natural language into controlled natural language, it's possible for the machine to basically do things with it, to derive new facts, perform inferences, and so on. When we thought about what we were doing in the context of Piroli and Card, however, we realized that there were already some semantics associated with this shoebox. The traditional foraging shoebox is basically a set of unstructured snippets that you then put structure on. But even though we keep all the natural language input, we can't help but start to put some structure and schematize the information. So it's proper to call what we have in that part of the sense-making cycle a semantic shoebox. Dave, next one, please.
Okay.
And that shoebox is really a sense-making blackboard. It becomes a space where users can contribute in all sorts of ways. They're not only restricted to contributing facts, snippets, but they can also extend the model. They can add hypotheses. The shoebox, as this semantic blackboard, lets you move up the sense-making chain towards the higher level elements that when I hand back to Dave, that he will pick up on. And what's also interesting about it is you get a lot of provenance and context for free, because you know where the various pieces of information have come from, who submitted them, whether they agree or disagree with other pieces of information, and we can generate explanatory rationale for each piece of information that's in the shoebox. Next, Dave.
Okay.
So I mentioned those three quite restrictive control studies we did. Well, we did one wild experiment, which was much more in the form of really a natural experiment. So the NATO Summit came to town, and what we were interested in was all of the activity around that. And one of the interesting aspects of activity around it was the public protests that happen, the organized and perhaps not quite so organized public protests that inevitably follow an event like this. To give you some idea of the context, 9,500 police officers were brought into the local area from police forces all over the UK to provide security for, I think it was 60 world leaders, including Barack Obama. And there were quite a number of protests. Fortunately, there was no really major disruption. Crime was minimal, but we took the opportunity to follow all the protest activity in terms of where protests were occurring, who were the actors, when were they occurring, and all of the kind of snippets of information which give you a basic level of situation understanding. The vast majority of this information came from open social media. So Twitter, as it often is in these situations, was invaluable as a source of snippets. But we added further enrichment, which I'll go on to talk about in a moment. We also supplemented what was happening on Twitter with eyewitness reports, because we had 8 people able to go out and observe the situations. Next, Dave.
Okay.
And again. So, as I've mentioned, there's a certain blurring of the boundaries that occurs when you have a semantic blackboard. The distinction between foraging and sense-making is harder to pin down, and we spend a lot of time thinking about, well, at what point are we actually interpreting events through the blackboard? And I think the best way to talk about this is to move on to the example on the next slide. And this was actually literally the morning of the first day that Barack Obama arrived in the UK. He was about 20 miles away from where we were sitting, making sense of the situation. He visited a local school. We were very interested in the actors on Twitter who were most vocally commenting on what was going on. And we realized at that very moment that something that was missing in our model was the notion of stance, specifically whether someone had a political stance that they were for the summit, they thought it was broadly a good thing that was happening here, and those that were anti this whole thing, often because they were anti-war and had some anti-NATO stance. And within minutes, we were sitting around 2 tables. Dave was down in a different part of the country at IBM in the southeast, and we were sitting in Cardiff. And between us, through the knowledge base, through an audio channel, much like we're doing now, we extended the knowledge base. We put stance in there, and for certain actors, we very quickly were able to add their stance. And this allowed us to detect, if you like, what was the spin on certain events and certain tweeting activity. And I think it's a good example of an interpretive step where we were adding information that was perhaps moving more towards the hypothesis level, more towards the level of why things were happening, not just what was happening. And I do feel that stepped up the sense-making loop. So, Dave, if you could move us along one.
Okay.
And back to you.
Okay, yeah, so thank you, Alan. So we're coming towards the end now of the material we plan to cover. The little screenshot here is a zoomed-in part of the Pirelli and Card sense-making process. So we're really now at those higher levels. We're still in the same context as we talked about. So we're talking about our conversational human-machine interaction, using controlled natural language, allowing users to express themselves in normal, everyday English like we are now. But what we really wanted to show was that by using this very, very simple language, which basically just creates you a knowledge graph, much as you could create in many other ways, we're able to still support these higher level things. So, for example, we can apply higher level models. Alan gave a good example of stance, realizing that raw knowledge of what people are talking about is one thing, but contextual information, such as where they're coming from, so if they're reporting a crowd, and they're pro-NATO, in this case, they may report the crowd more accurately in terms of size than someone who's anti-NATO, who it would be advantageous to have large, more perception of unrest. Now, we have to be obviously very careful with these because there are two things going on. One is that by defining these higher-level concepts, we can take advantage of things like machine reasoning, logical inference, the application of machine learning algorithms, for example. And, of course, they aren't human. They may infer things that are logically sound but not actually grounded in reality. We also have a similar problem with humans, which is we're extremely good at having insight and seeing things and then sort of trying to figure out why. We're trying to build a picture of the rationale for why our hypothesis might be true. But the good news is we can support an environment that operates at that level. And you can have this hybrid team of human and machine agents working together with perhaps the machine agents doing some of the heavy lifting, running inference rules across very large knowledge bases, and the humans looking at the system, visualizing it, sharing information and talking to each other to try and get those insights that it's extremely hard for machines to do. The final part of the Pirelli and Card story is all around storytelling and presenting the information that you've managed to gather. And this is really, from their perspective, where the process ends. This is normally if you're an intelligence analyst where you brief the commander or you talk with colleagues. We did some work. We often try these ideas with other clients, and last year we did some work with one of our intelligence agencies to try and take this same underlying basis, this knowledge representation using the English language, and render things like conversations, but in the form of a comic strip. And the idea here was that if you've got all this knowledge in the knowledge base, you can actually have the machine reason over it. You could actually have the visual information, such as where the person is, what sex they are, what mood they're in, what their tone of voice is suggesting. You can actually render a lot of this stuff using pictures. And this might make it more efficient for human readers of large volumes of transcripts to consume. It was a very, very small consulting piece of work, but we gave a little great demo there, and I think there's a really nice story of how even at that highest level you can apply presentation and storytelling techniques on this basis. So that's it. I know we've gone through it very quickly. We're on the summary slide, and we'll hand over for questions in a minute. We've talked about a lot of things. We've talked about our underlying controlled natural language approach. We've talked about our conversational model, and we've talked about the sense-making process and how humans and machines work together. Alan, I'm sure there's a couple of points you'd like to add, and then we'll open it for questions.
Well, we've got a few seconds. I just want to emphasize, I suppose, that the final point, that the experiments are ongoing, and we're also collaborating with psychologists. I mean, neither Dave nor I have a psychology background, but in the design of the experiments and the execution of the experiments, we do have psychology expertise on tap, and so we're continuing these kinds of crowdsourcing and situation understanding experiments, and in fact we ran a couple just before Christmas, and we'll be running another one in 3 weeks' time. So this is very much ongoing live work.
Okay. So that's the final slide, and we just like to remind everybody that this great work that we've been doing for nearly 10 years now is sponsored by both of our governments, and it's what we call fundamental research. So it's really the most basic science, and good outputs from this are things like papers, experiments, patents, and so on. So thank you for listening.
Thank you.
Thank you, Dave and Alan. This is very cool and very interesting. And is this something that will be commercialized?
So, Diane, I hope so. I think the pattern of what we're doing is definitely something I think that will be of increasing interest. What we have done, which is something that's directly within our control, is we have created open source software for the two components that we work on, both of which are built around this controlled English. So we have one component called CE Store. CE stands for Controlled English. I'll send you links afterwards. And that is something that the IBM UK team built with great input from Cardiff and others. And the other is CE Node, which is a similar environment but designed to really work at the network edge in your browser on your mobile device, which was led by Cardiff.
That's really fantastic. All right, so we have some folks who want to ask questions. Audience, please press *1 to unmute your line. And Hunter has a question. Hunter, can you unmute?
Yeah, thanks, Diane. This is Hunter. Thanks for the presentation. You stated that subjectivity can be computed. I wondered if you could expand on that statement briefly. How can it be computed?
Sure. Do you want me to start with that one, Alan?
Yeah, go for it, Dave.
So the program we mentioned, the research program, the ITA, is much broader than what we've briefed you about today. One of the focus areas on there is what we call subjective logic, which is a term I'm sure you're familiar with, but it's basically trying to characterize the belief, the disbelief, and the uncertainty of facts. And if you were able to see me, you'd see me making air quotes at that point. Facts, of course, are rarely universally true, but if I say that Fred was in the pub yesterday and Alan says Fred was at the airport yesterday, if we're talking about the same Fred, they cannot both be true. So what we want to do is try to understand the subjectivity, the belief, the disbelief, and the uncertainty. And what we mean by that is two things. One, in our controlled natural language environment, we have done previous work to express subjectivity. And the other is that other researchers on the ITA program are looking at mechanisms for computing across knowledge graphs that contain subjective data.
Good, thank you.
Are there other questions? Press *1.
Hello, this is Scott McLeod from World University and School. I'm curious, thank you for a fascinating presentation that introduces many potentials for interlinguality, multilingualism, plus translation. And I'm wondering if your schemas have begun to address some of these questions, perhaps on the Twitter data side of things, or in your actual model, initial model, Paroli et al.
I don't know. Dave, did you want to say something perhaps about, I know there was some attempts at Hersley to deal with other languages. I can say a bit as well.
Yes, one of our research sponsors, which is Army Research Labs in the US, has done extensive work with other languages, especially on Twitter. One very interesting thing they've done is try to identify language dialects in sub-Saharan Africa, and often these languages aren't often even written down. It's not something we've done a great deal of, but one thing we've observed is that because of our approach of going from natural language to controlled natural language, which is the knowledge graph, there is a form of translation between languages that should be fairly straightforward because it's a very simple computational transformation. I know that's not really answering your question. The short answer to your question is no.
On our side, because we do have quite a strong interest in Twitter data, the basic approach would involve running tweets through translation services. So that isn't really our focus. But there is one interesting issue that the knowledge representation is meant to be a form of English. So if you're working in another language, you would expect it to be a structured form of that other language. And we're just in the process of beginning. I live in a bilingual country. This part of the UK has two languages, English and Welsh. and we're about to start a project in association with the local Welsh government to look at what controlled English would look like in Welsh, that it's not about translating content, but actually allowing people to express their models and facts directly in the native language. And so hopefully we'll be able to report back on that. It's quite a politically hot one locally to be able to do that, so we're looking forward to doing it.
Exciting. Thank you very much. I hope to be in touch via email.
Great, thank you.
Thank you. One other slightly relevant point is we have looked at trying to mitigate miscommunication between human users. So our use case here is that in a coalition of US and UK members, there are sometimes phrases that mean different things. And we have had the concept of a machine agent that's been primed with knowledge of those phrases, able to assist users, human users, when they chat, and just remind them that they may be ambiguous or misleading at this point.
Interesting.
Well, we're about out of time. Actually, we're a minute over. So let me thank all of the audience for participating today. Thanks for the great questions. A special thanks to Dave and Alan. This is very exciting research work. Thank you for sharing it with us and sharing your expertise. We will have another call next week, and we'll see you all then.
Thank you.
It's been a pleasure. Thanks for listening.
Thank you.